Hey there guys, it's your favorite backyard geographer and geologist here with another presentation, this time on sedimentary rocks. So really the purpose of this presentation is to walk you through the different types, how they develop, and some of the basic identification tools that we can use to distinguish and identify sedimentary rocks. So let's get going. Alright, so let's begin. So what are sedimentary rocks? So they are produced from the weathering of pre-existing rocks or accumulated biological matter. Sedimentary rock types and sedimentary structures within these rocks give clues to past environments. Fossils in sedimentary rocks give clues to the history of life. And lastly, important resources such as coal and oil are found in sedimentary rocks. Now we can really break this down into three families. You have what we consider detrital, which is clastic. We have chemical, and then organic types of sedimentary rocks. So when I think of clastic rocks, those are rocks that are produced by fragments and that they have been glued together. Chemical rocks are produced by the precipitation or the evaporation or dissolved ions in waters. When I think of chemical rocks, I think of things like, as an example, in your shower, on the shower head, the little minerals that build up on the little sprinkler part of your shower head. Those are chemical sedimentary rocks being developed. And organic rocks are just the accumulation of biological debris often found in swamps or bogs. So like a peat moss, or even, well, I guess a peat moss is probably a great example to start with, which is just like a compacted moss. And then that can then manipulate and transfer into other things with a little bit of pressure. So I start off with the crumbs of the earth. So when I often think of just the sedimentary process, I think of Oreos, because who doesn't like Oreos? They're vegan, right? So you eat the Oreos, and when you're done eating your Oreos, what's left are the crumbs. You had pre-existing rock or cookie that has been broken apart, and what is left behind are the crumbs or the sediment or remains of that once existent parent rock. So it says sediment are loose, solid particles originating from the weathering and erosion of pre-existing rocks, and also the chemical precipitation from a solution, including secretion by organisms within that water. So what we do is this sediment, we actually can classify by its grain size. We like to classify things. We often do it by grain size, especially when it comes to sediment. So we have, the smallest being clay, then silt, then sand, pebble, cobble, and then boulder, and those top three are broken up into the common generalized name of a gravel. So the crumbs of the earth, where do we start with? We start with some parent material that has undergone some type of weathering and erosion to leave new, smaller, broken bits and pieces that we are going to then turn into a new type of rock, a sedimentary rock. So when we think of just that process, erosion, weathering, erosion, transportation, deposition, what's really important to know is that when you have any type of erosion, that material will be transported somewhere else. So here we can see with transportation, it's the movement of sediment away from its source, typically by water, wind, or ice. In that process, those materials will then roll along by that type of motion, which will create a rounding effect generally. So rounding of particles occurs due to the abrasion during that transportation. Then a type of sorting will occur as the sediment is separated according by its grain size by transport agents. So as an example, maybe a lot of material is being washed away into maybe a large lake bed. What we find is that the heavier material will sink first, and then based on grain size, it will naturally layer upon itself, creating essentially a miniature stratigraphy. Sediment size will decrease with increased transport distance. The farther it goes, the smaller that material will be. Here's a very simplistic diagram showing that this is where the rock is coming from, and it's being rolled along, and as it gets rolled along, it's changing its grain size because it's getting weathered and broken down as it's being transported to even smaller bits and pieces, into even smaller crumbs. So it goes from a sand and gravel to a silty clay, and then it finally kind of goes out into a mouth of a river, into a large body of water where it'll settle, and it could probably be more of a clay deposit itself. So this is a nice little showing. The blue line represents the velocity when you have more of a slope. We often find in fluvial or river environments, the greater the slope, the faster that velocity, but usually it ends up kind of flattening out and slowing down. So preservation and lithification. I love that word. It's a good Scrabble word. Lithification. So preservation. Sediment must be preserved as by burial with additional sediments in order to become a sedimentary rock. So it must be collected, otherwise it just keeps washing away. Lithification is the process of those crumbs, that sediment, being converted into a rock. It's being compacted, and then through the process of cementation, it glues together. So, of course, I didn't plan very well for this. I've got. Doesn't everyone have one of these? Your box of rocks that you just gotta keep at your desk. But looking at my box of rocks, oh, here's a good example here. So it's gonna be very hard to see, but I'm gonna show you nonetheless. So these are grains, some being more coarse than others, that have been lithified. They've been glued or they've been cemented together to create a new type of rock. That's because of their grain size. They are rounded. We'll learn about this later. Since these little chunks that are in here, looks like almost like a cookie with all the nuts and stuff in it, but since they're rounded, we would call that a conglomerate. If they were angular, we'd call that a breccia, or a different name. Oh yeah, I'll look more at these later. I mean, I'll share them with you, but we'll keep moving on. So here we have, I want to break each, so we kind of talked about it before. We've got clastic, chemical, and then a little bit of biological types of sedimentary rocks that we can talk about. So this part of the presentation is really going to be just identifying what they are and some of the types of rocks that fit within that. So as an example, the first one is a breccia or a conglomerate, traditionally more coarse-grained. As you can see, very large. You can see very easily with your naked eye, like the size of an eraser head. So sedimentary breccia is composed of coarse, angular rock fragments that have been glued together. On the other hand, conglomerate is a rock that is composed of rounded cobbles and gravel that has been cemented together. So same process, but one's angular, one's more rounded. And I know, like I said, I kind of showed it to you, and I don't know if you'll be able to see. I'll try a little closer, but kind of. They're very small. Again, smaller than the eraser head, some bigger, but they're all been smoothed out to that transportation process. Another type of classic sedimentary rock is like maybe a sandstone. So sandstone's very common. I do this activity in my class where we do like identification, and people are like, I don't know what type of rock this is. You know, they're feeling that texture, right? Because we distinguish these based off of their composition. And you know, a quartz sandstone has to be 90% quartz. But you know, you're looking, it's like, well, what does it feel like to? And it's like, well, it feels very sandy. And it's like, you're right. Yep, it's sand, very sandy. So therefore, it must be a sandstone, right? So this is a piece of like pink to red sandstone. You can see some layering in there as well, which is neat. Very sandy in texture. So again, sandstone, it's more of a medium grain, determined by its composition. We also have different types of that type of rock, different varieties. So you have a traditional sandstone, and then you can have an arkose, which is mostly feldspar, and then you have a gray wacky, which is the sand grains surrounded by dark, fine grain matrices, and usually often rich in clay. So you have different types. You have like sandstone, then you have different varieties underneath it. Moving forward, we can even look at smaller grain material, like a shale, a silt, a clay, or a mudstone. So again, it's predominantly what it's made out of. So shale is very fine grain, silts and clays, classic sedimentary rock that splits into very thin layers. Those thin layers are super important because in most shales is where we're going to find either we can find oil deposits from pre-existing biological matter, which is great, or we'll split those layers off very evenly and nicely because there'll be fossils found inside as well. Siltstone is slightly coarser. It lacks facility, which means that it doesn't peel nicely or breaks in those pieces into sheets. As we can see in this photo here, we can see those nice parallel sheets that are found. Claystone is predominantly clay-based, and then mudstone is literally can be very massive. When I think of mudstone, it's like if you have like a big backyard or an area that's mostly dirt and it rains a lot, like it's been raining in California this last year like crazy, and then all that mud gets wet and then the sun comes out and the water evaporates, creating mud cracks. Well, it's turning that loose material of mud into a mudstone. So it's turning it into a rock, which is pretty cool. And this is an example here at bottom of a mixture of shales, clay stones, and mudstones that can be introduced into environment. Because remember, when looking at the laws of stratigraphy, whatever's in the bodice is traditionally going to be the oldest. And so when we see multiple layers, it's assumed that that it's different time. So whatever's in the bottom was really, really long time ago, and what's on top is more recent. So, maybe this location here has experienced multiple times of being submerged by water or being material being transported in by rivers or streams. So chemical, different types of chemical sedimentary rocks. We have carbonates, we have a chert, which is very common, and then you have evaporates. So carbonates contain CO3 as part of their chemical composition, limestone as well. When I think of chemical sedimentary rocks, I think of, especially the carbonates, I often think of them as being like a solid mass, not necessarily being, when you find like a fossiliferous shale where you can still see the fossils in it. When I think of chemical sedimentary, it's usually because they've been dissolved, so it's not as chunky. It would be harder to distinguish, except for you can check it. Sometimes you can check some of these with acids, like in limestone, and if it dissolves with traditional hydrochloric 10% acid, then you know that it has some type of calcium in it because it's dissolving, creating a gas. Chert's unique. Chert reminds me a lot of obsidian, but it's a very different process. But it kind of reminds me of that because a lot of early indigenous tribes, if they did not have obsidian, they might use flint or chert, because chert has the ability, because it's a very hard, compacted, fine grain material, even finer grain than sand, and so it almost fractures like that of obsidian. Like you can create an arrowhead out of chert. It can occur as layers or as lumpy nodules within other types of rocks, especially limestones. And then evaporates are what happens when water evaporates. So if you've ever boiled water before, you're making macaroni and cheese, you're boiling the water, you walk away, you come back, and you're like, oh my gosh, I forgot to turn the water off. What's usually left in the bottom of the pan is white powder. That white powder, it's mineral rich. It's minerals that were within, completely dissolved in that water. When the water evaporates, it cannot take the minerals with it in that change of matter, going from a liquid to a vapor, so it leaves it behind. This is a photo of Death Valley. Death Valley at one point was a massive freshwater lake known as Lake Manly. The water evaporated, leaving a tremendous amount of material behind. Common types are going to be rock gypsum, rock salt, your borates. Those are very common as well. But those are the type of rocks that are left behind when water evaporates itself, which is pretty cool. So what about organic stuff? Okay, so usually in my lectures, I just stick with chemical and clastic, but I think it's important to bring in just the fact that there can be situations when you have 100% organic stuff. So like the most iconic would be coal. It's a sedimentary rock forming from the compaction of partially decayed plant material. So again, you're looking at those places that are like marshes. A great example of that would be the Okefenokee swamp out in Florida. That really rich organic material, it gets compacted, and in that process will create these blocks or rocks of coal, which is neat because then we can use coal, we can burn it, and it has a stronger fuel system and source than normal like wood. But also, you can take coal and you can add heat and pressure through the metamorphic process, which we'll talk about in another video, and you can actually change coal into anthracite, which is called a hard coal, which burns even hotter. But anyway, I digress. Another one would be like oil and natural gas. So it originates from that organic material in marine sediment that maybe was buried very deep beneath the Earth's surface over time. So those layers were deposited, and then as things decompose, as things change or are given pressure, they can manipulate, and then you create these pockets of oil or gas, and sometimes even separate within the solutions of water. They can also accumulate in porous overlying rocks. Like when we think of fracking, so they're drilling down and they're fracturing the rock, they're exploding it, because by exploding that rock, that sedimentary rock, it's releasing those gas pockets or those oil pockets in which these organic oil or natural gas has been accumulated, and then they can pull it out from there. So that's some examples there. And then structures. So we've certainly looked at little stuff, but when you have a lot of little stuff, you're going to get big stuff. And so we can look at what we consider sedimentary structures. So there's things called bedding, which is a series of visible layers within the rock. So we can see, if you want to, because imagine this was much bigger, but we can see that it does have some bedding, it has some layering. But maybe it gets more complicated. Maybe you have, instead of being just a flat sand, maybe you experience cross bedding. Maybe you have sand dunes and the winds change directions over eons, and then because of lithification, those sand dunes get stuck. You get something that looks more like this. This is a great example, this photo here, of some cross bedding, which is a series of thin inclined layers within that horizontal bedrock. We also may see ripple marks, which are small ridges formed on the surface of sediment layers by moving wind or water. So ripples are like those little, if you look in a river, you'll see as the water's flowing under a very small river, that you'll see the little ripples that develop. Well, imagine that those ripples are able to become lithified. They're able to become solidified, and that becomes a new rock. But then, if that happens over and over again, you can see multiple layers over time. You have graded bedding, which is the progressive change in grain size from the bottom to the top of the bed. Mud cracks, super iconic. I mentioned that earlier. You have that mud, it gets wet, the water evaporates, usually creates that nice polygon or hexagonal type of shape. Not hexagonal, sorry, it's more like a honeycomb. And then last one is fossils. A very iconic structure. It's traces of plants or animals that are preserved in rocks. So, as an example, in my box that I have down here that I was kind of playing with, showing earlier, here's one. This is great. This is a brachiopod. So it was at some point essentially a sea animal. It was the shell. The shell has been preserved, and then we were able to exhume it out of a type of shale. Like I said, I've got sandstone. Here I did mention shale. We're gonna find some shale. The problem is, I opened my box, and you know what? It's not in order. I think I must have dropped it. I didn't put it back in place. Well, I can start with this. Oh, here it is. Found it. It's kind of hard to tell. These are really small pieces. This is a nice piece of shale. You can see it's got some, it wants to break and kind of peel off in layers. This is a really fun one. This one here. It looks like oatmeal, but it's not. It's actually seashells. It's called coquina. Coquina is a very common sedimentary rock found in areas that may have had shallow warm waters. And it's literally just broken up seashells that have been lithified together. It's in the limestone family. And then I'll find one more. I want to see. Oh, here we go. This one's rock salt. So it's an evaporate. So yes, halite is a mineral, but when we find it, when it's been dissolved and then reclassified, because the water is evaporated, it recrystallizes into a larger rock. They call it a rock salt. There's some fun ones in here. Oh, what's this one? Oh, I've never looked. I guess I haven't spent much time looking at my box. I'll get distracted, so I'll move on. But lots of different varieties, but we can break them up into those three families, and then we can put those rocks together to make something bigger. So let's wrap up this part here. I know that I've kind of lumped in our organic with our crystalline or chemical, but this is our flow chart. Starting off, sedimentary rocks forms from the compaction and cementation of sediments, and we can say that clastic rocks on the right, Clastic is compacted sediment, and it's classified by its grain size, simplistically. And then organic and mostly crystalline, you have evaporites, precipitates, and then you have biological matter. So this is your very simple flow chart. You can throw that in your table if you've got one of those going. I hope that was helpful. A nice quick walk through sedimentary rocks. Don't forget to click like and subscribe, and check out the next video, which is going to be on metamorphic rocks. We'll talk soon.